So in this tutorial we will talk about blocks, and blocks have an odd syntax which will confuse you if you are not familiar with function pointers. Now I have made already a tutorial on function pointers, and I think you should look at it before you look at this tutorial. So I assume from now on that you are familiar with function pointers, so let's start our talk about blocks. We will begin by going to Xcode and creating a new project. Let's call it, well, let's make it command line tool, and let's call it blocks, and save it on our desktop. Let's tidy up a bit. So, and here we'll put our code. Now let's begin with a comment first. The key to understanding blocks is to understand the type of the block. I will explain what I mean by this in a little while. But let's first take a look at some code that you are familiar with. If I write something like int f equals 6, then this 6 is called a literal. And this int is called the type. And this is the variable name. So we have a name, a type, and a literal. Now the same applies to blocks. Now the type of the block is a specification of what goes in and what goes out. So for instance, we can say that this block produces an int, and it takes an int as parameter and another int also as parameter. So the type of this block is that it accepts two integers and outputs one integer. And now we go over to the name, and normally we would have the type and then the name like this, but in C we don't use it like this. Instead we specify functions inside the type like this. Now since we are if you remember, when we are dealing with function pointers, we define the pointer to the function like this. So this is a function pointer that accepts two ints and produces one int out. When it comes to blocks, it is similar, but instead of star, we use caret. So this is a block. This is a block with the name of func and the return type of accepting two integers and outputting one integer. So just like we had here, we need to have equal sign and then a literal. So we will write equals and then some literal followed by a semicolon. Now the literal must have the same type as what's on the left side. Just like this 6, it is an integer. So we must also have. So we might think that we should write something like this: int, then the caret, and then as input accepting an int, accepting 2 ints, something like that, and then something inside here, and then a semicolon. Now, when we specify things inside here, we need to refer to names. So we will give those 2 parameters, names, nmn, and we shall return n plus m. Now the compiler can see that these are 2 ints and this is a return of 2 ints, so it can infer what output is. So we don't actually need this. This is all we need to specify the input parameters, and the output type can be inferred. So our literal is this. This is our literal corresponding to the 6 here. And the literal is followed by a semicolon, just like the 6 here is followed by the semicolon. Okay. So let's comment out this and start to use this. Now, to use this, we have to call this block, and we use it by calling f and then some, no, not f, func, that was what we called it, func, with some 2 integers as input parameters, like that. And let's now output this to the console, see, and see what we get. Now, as you can see, we get 15, and that is what is to be expected. Now you see that now if you look at this syntax, it looks a little weird, coming from the fact that you are putting the name of the block inside the type. There is a way to make this look a little nicer, and that is using the typedef trick. So let's write typedef and then say that this typedef accepts 2 inputs and gives 1 output, integer output, and we can call this type definition, we can give it a name, call it func type. And what we can do now is just to say that our func is of type func type, like this. So let's try this and see if it works. And as you can see, it works just fine. So this is using the type definition. It's a nicer way